We have the signal xt that looks like this, and we want to find the even and odd components. So we know that the even components of a signal is given by this equation, and the odd component of a signal is given by this equation. So to sketch the even and odd component, okay, we know the original signal, how it looks like. It looks like this. Then we need to find the x minus t of the signal. So let's sketch that. So x minus t is just reflection of the signal along the y-axis. So when we want to find the even and odd components, we always look from left to right. So if we want to find the left to right, so we have to make sure that we cover all points. So since the x minus t starts from -4, so we have make sure we plot first, yeah, so that we don't miss any points. We have, let's see, that point. Let me just sketch, put down all the points first before we proceed. Yeah. So okay, let's see. We have that. Okay, so from left to right, so we can see here for xt at t equivalent to -4, the value is 0. But for x minus t at t equals to -4 is also 0. And as we're coming from left to right, okay, for both the sketches, we can see that the value is 0. So we have the xt minus xt plus x minus t divided by 2 is 0. Okay, and then from from -4 until -2, we see that xt, yeah, has 0 values, but for x minus t, we have an increasing value from 0 to here. So this point is approximately 1. Yeah, this is approximately 1. So we have, if we check at point -2, let's say this point at point -2, so we can see that it is 0 plus 1 divided by 2. So that means this is more or less half. Let's say that is 0.1/2. So from 0 it goes to amplitude half, 1/2. And then from this point -2 until 0, we have an increasing value. And for x minus t also, we have an increasing value. So at point t equivalent to 0, we can see that is 2 plus 2 is 4, divided by 2 is 2. So at time equivalent to 0, the even component will have the value of 2. So it goes from half goes to 2. I'm not drawing this to scale, but I think you get the idea, yeah. So on the right hand side, now we have let's say from point 0 until 2, okay, it decreases. For xt, for x minus t also, it decreases. So from at point 2, yeah, at point 2, now we have this value. This value is more or less 1. Yeah, the thing is 1. So 1 plus 0 is 1. Divided by 2 is 0.2. So at this point we have that's about that. So it goes there. So I think you can expect for time between 2 until 4, yeah, it will be a decreasing value from 1/2 half until 0, and it is 0 for the rest for t bigger than 4. So that is x e t, right? So now for x odd, okay, again from left to right, So we have 0 minus 0 is 0. Okay, minus 4, minus 2. So we have 0 for that part. And then when it comes to between minus 4 and minus 2, we have 0 minus something, right? And divide by 2, so you make it even further smaller. So at the point minus 2, we have 0 minus 1 and divide by 2, so we have minus half. So I think it's 1 over 2 there at that point. So I'll just get rid of that here. Trying to plot. Okay, so we have from there until half, yeah, that point. And then from point minus 2 until 0, we have an, this value we have to minus with this value. So if we check at point 2, we already know that it's minus half. Now if we check at point 0, we have 2 minus 2. Okay, that's 0. So that means that point will go to 0. Okay, that is point half. And that point is 0. This is minus half. This is 0. Okay, and then from 0 until 2, t equivalent to 0 until t equivalent to 2. So you have this value decreasing and this is decreasing. So at this point is 1 minus 0 divided by 2. So you have positive half. Okay, I forgot to okay, so we have that. Okay, so we have positive half, let's say it's there. So at that point we have, okay, that is 1 over 2, right? And then we have decreasing value. We have this is going down. This is let's say just before. Maybe we can check just just before the time equivalent to 4. We have a value here. Maybe okay. Maybe this is half. Okay, this is half here. Amplitude is half. You minus it with 0, so you get half. And you divide it again, so it's going to be even smaller. So and then for at this time is after t equivalent to 4, you have 0. So you have something that looks like that and that. Yeah, so again you can check by adding these two signals together, the odd and the even components. So you can check. Okay, let me just draw this again. So from left to right, you add the two signals together. From point minus 4 until minus 2, you have half plus minus half. So you get 0. Okay. So for 0, there you have 0. Okay. And then from minus 2 until 0, you have an increasing value here. This, let's say this point, okay, is increasing value up there, but you have to minus. Okay, you have to subtract this value. So you will have an increasing value. Okay, until point t equivalent to 0. You see this is 2 plus 0. So you have 2. So from that point until t equivalent to 0, you have the magnitude 2, right? And then from 0 until 2, you can add. Okay, you have this part, add to this part. Okay, I think you can expect this is half, this is half, so you get 1. So that point 1 there is there, so it goes there. And then from 2 until 4, 2 until 4, yeah, from 2 until 4, so you have that amplitude which starts from half, and that also starts from half. It goes towards 0 at time equals approaching 4, so it goes down to 0 as time approaches 4. So that is how you check. So you see that this signal, which is addition of the even component and odd component, gives it looks the same as the original signal that you have. So that means your sketch for the even and odd components are correct.